So we are going to talk about now a problem like this. So Eli, we're going to talk about a problem like this. Find the tangent of the angle whose cosine is 3/5. All right? So I'm going to say that again, because if you can say it, it becomes much easier to do. If you just look at it, it looks hard. But if you can say it, it's so easy. Find the tangent of the angle whose cosine is 3/5. So somewhere out there is an angle, and his cosine is 3/5. Now, yesterday we learned where we were going to look for that angle. This is a cosine problem. What's the rule for cosine? Top half. So it's in 1 or 2. So we are looking here. Since that is a positive number, it's quadrant 1. And the cosine is 3/5. Cosine is 3/5. Does that picture make sense to everybody? So we do a little Pythagorean theorem. Works out awesome. It's 4. Now, you've seen a 3, 4, 5 triangle before, but you have no idea how big these angles are. But it doesn't matter, because we're not looking for the angle, we are looking for the tangent. So the answer to the question is 4/3. Opposite over adjacent, 4/3. Now, let me step it up a notch, make it just a little bit trickier. Find the cotangent of the angle whose cosecant is -3. All right? Okay, so I'm going to say this again. Find the cotangent of the angle whose cosecant is -3. Now, wait a minute. Cosecant. I got to know where to draw this, right? I got to know the rules first. Where do I draw that? I didn't give you that yesterday. I didn't talk about cosecant yesterday. What do you think you're going to do? You're going to think of it as a sine. If you have an angle and the cosecant is 3/1, then isn't the sine of that angle 1/3? Right? Remember, they're reciprocals of each other. So if hypotenuse over opposite is 3/1, then opposite over hypotenuse would be 3 or 1/3, right? Okay, so now I'm going to draw this angle. Where shall I draw that? That would be in the 4th quadrant, right? Because it's got to be on the right half, and it's a negative number, so it's got to be down here. Now the sine is -1/3. Remember, hypotenuse is never negative. Hypotenuse is never negative, so the negative's got to go on the 1. This one doesn't work out so great. So what's this side going to be? Not √10, watch it now. A squared plus b squared is c squared, and this is c squared. Hypotenuse is always c squared. So it's going to be the square root of 8. 9 minus 1, the square root of 8. So it's 2√2. Positive. Cotangent. I'm hearing it. Adjacent over opposite. So 2√2 over -1 or -2√2 is the answer to the question. All right. Now, with your partner or your groups of 3, whatever, I want you to do one. Before we move on. So here's what I want want you to do. I want you to find the cosine of the angle whose cotangent. I know, yeah. The angle whose tangent is
Miss Ford.
Yep.
Will we ever see like the ones where it'll be like cotangent, tangent?
I think I know what you're saying. Let's do this one first, and then I'll write one down.
Okay.
I think I know what you're saying. I'm not positive. All right, let's try this one right now on your own with your friends. Work together, or do it yourself and check it. Yes, Jane.
So it was like kind of like 0? No.
We're gonna do one of those.
Okay, because I was in the
You're a little tricky, yeah. Well, 0 and 1 are special. You remember, they happen on the slope. So we're not going to be drawing the triangles, we're going to be looking on the slope. Okay, but we'll do that in a minute. Let's do this one.
Oh yeah, you're right.
More Clark, are you focused?
Yes.
All right.
I always do that.
Yeah.
What's a negative? Remember, you have to then multiply by root 29.
Oh, yeah, 5 root 29 over 29.
I did it wrong.
I'm done. 5 root 29, everything on this.
All right, I've got a suggestion from Mr. Cohen here that the answer is 5 root 29 over 29.
Yes.
Anybody want to disagree?
Oh, wait. Is it negative?
I don't know.
I didn't hear what the answer
He didn't say negative. He said it's positive.
It's positive.
For instance, positive is positive. Do you think it's negative? Here we are in quadrant.
We're doing quadrant 1, 2.
He's got himself in the wrong quadrants. That's easy to do. You got to keep it straight. We are in quadrant 4, and this is -2, and this is 5, and this is root 29, and I think Michael's right. 5 over root 29, or 5 root 29 over 29. Now, there are 2 questions that surfaced through that. Oh, by the way, when you return from lunch, you're going to get out a half sheet of paper, and you're going to do one of these. No! Okay? So, here's the deal. We just practiced one together. Everybody except Burkhart was in agreement. It's 5 root 29 over 29. So, you got lunchtime to get it sorted out. If you don't get that, either with me or with, one of your... Huh? We all have lunch together. But we're not going to lunch right now, Brenton. Okay? I'm telling you, when you come back from lunch, that's what you're going to do. Jay? No. But what we are going to do, actually sort of we are, but not really. What we are going to do is take care of these 2 questions that came up. One of the questions I am not quite sure about, but I think this is what it might have been. So let's talk about
Yes,
this.
that's what I was asking.
Okay. Now, this question you could do this exactly what how we just went through it. But really, this is one of those who's buried in Grant's tomb type questions. Because what does this say? What is the tangent of the angle whose tangent is 3/4? So there's some angle out there whose tangent's 3/4. What's its tangent? That's what this question is asking. So the answer is just 3/4. You could go ahead and draw that, but the tangent is just going to turn out to be 3/4.
Okay.
So these are inverses of each other. So they effectively cancel each other out, and the answer is just 3/4. Okay? So don't panic when you see that. It's really very simple.
Didn't like your feelings.
The first one was cotangent, which you just proved.
Yep, it'd be 4/3. If it said what's the cotangent of the angle whose tangent is 3/4, be 4/3. Now again, you can always draw it out like we've done. But if you have the same function, or like Mallory said, reciprocal function, so if you had, what's the sine of the angle whose cosecant is 5/3? The answer would be 3/5. Now, if that doesn't make sense to you or you're confused by that, then just go ahead and do it like we did it here, and it'll come out to be 3/5. All right, so that's one question that we have. The other question, Jade has been doing some homework, God bless her, and she said, you know, Mrs. Ford, I get all this, but there were a couple of questions, things like this. Find the angle whose sine is 1. Or find the angle whose tangent is 0. Or find the angle whose cosine is -1. These are special situations. It is not possible, if you think about this, it is not possible to have a triangle where the opposite side is 1 and the hypotenuse is also 1. Why is that not possible? Hypotenuse has to be biggest, right? If it's not possible, think back to all the other problems that we did. If it's not possible to draw a triangle, where do we look? We look on our circle. Instead of using the opposite over hypotenuse definitions, we're going to use the y over r definitions. Okay? If you can't draw a triangle, then you look at your circle. Zeros, ones, and -1s almost always mean look on the circle. And that makes sense to you because what's my favorite radius? 1. So what are these points around here? They are full of zeros, ones, and -1s. That's where you look. Okay? Now all the rules still apply. So when we say sine, we aren't looking at the whole circle. We're only looking at this much of it, right? Because it's sine. So where is the sine going to be 1 over 1? Where is y over r going to be 1 over 1? Right here. Because right here, x is 0, y is 1, and of course r is 1. So the answer to the question is 90 degrees. Straight up. That's where the sine is 1 over 1.
Are they all going to be coterminal?
Yep. If there's zeros and ones, except for the tangent. The tangent can be 1 at 45, but every other 1, 0, or -1 is going to be a coterminal angle. All right, so I want the tangent to be 0. So where am I looking? I'm going to look on my circle, but not the whole thing. I'm going to look on the right side. And I'm going to look at these points right here. And I'm going to figure out where y over x is 0 over 1. So where does that happen? If I put y over x, where do I get 0 over 1? On the x-axis, that's 0 degrees. So the answer is 0 degrees, right there at the starting point. All right. We have not used our, what are called the circular definitions, y over r, x over r, y over x. We haven't used those a lot, but they are necessary whenever you have quadrantal angles. We said coterminal, we meant quadrantal.
Oh,
Yeah. It's all right. How about this one? Where am I going to look? It says the cosine, the inverse cosine. So no matter what the number is, inverse cosine means I look up here, right? Since it's a 1, 0, or -1, I'm going to look at these points right here. And what do I want to have happen? I want to get negative 1 over 1. So I want x over r to be negative 1 over 1. Now r's 1, so I don't need to worry about that. Where is x negative 1? Right here. What angle is that? 180 degrees. Okay, Jade, see how to handle those now? Okay, that's how we do that. That came out of homework. There are some in the homework like that if you're like Jade and you started it, you know that. If you haven't started it yet, I would strongly recommend you get that done this weekend. Okay? Definitely. We're looking at maybe that being due in about a week. So we really need to keep moving because now we have the word problems ahead of us. All right? No panic.
This 4-8.
No, this is still 4-7. These are problems in 4-7. Yep. 4-8 is just word problems.
Oh wait, that was 4-7?
No, the quiz when you come back from lunch. Okay, Jade, I'm going to do one more because we got confusion. One more. The quiz when we come back from lunch is going to look something like this. Find the cosine of the angle whose sine is negative 3/4. Something like this. That's it. One problem. All right, so do it. Take 2 minutes and do it. Then we're going to finish our review sheet, go to lunch, and we come back. We'll take our quiz and do the word problems. Where'd you draw it? Did everybody draw it in the 4th quadrant? Okay. Did you label this side negative 3 and this side positive 4? Did you call this root 7?
Yes.
Very good. Nobody said 5, right? Don't admit it if you did, because the hypotenuse has to be longer than everything else. All right? Now, what do I want to know about this angle? I want to know its cosine. Root 7 over 4 is the answer to the question. What?
What if you Pythagorean theorem doesn't that equal 6 or doesn't?
16.
Yeah, plus.
No.
Oh, my bad. Yeah,
Minus
right.
9. All right. That's that. Get out your page 6 of your packet. We got 2 more to do. Then we'll be done with this sheet. We'll quit getting it out, but it's good review. Especially the first one because it's a little word problem and it's going to get us in the mood. So one problem on the quiz, it's going to look like this, right? That's what it looks like.
Only one.
One problem on the quiz.
Completion. I thought you said the test.
Well, you better get it right because one problem on the test. You better get it right. All right, number 6. Find the length of a shadow cast by a 16-foot pole. So here's my 16-foot pole. Here's the ground. Sun's up here somewhere. So it's shining down on the pole. And here is the shadow. Would everybody agree this right here is the shadow of the pole? And your job is to find the length of the shadow if the angle of elevation of the sun is 27, this is called the angle of elevation. Because if you are looking up at the sun, which is a bad idea, but if you are looking up at the sun, the angle that you would have to tilt your head through to look up is your angle of elevation. So that's the 27 right there.
Would you use like tangent, cotangent?
Well, we're going to use some trigonometric function, so we got to decide which one it is. Now, why did you say tangent, Brenton?
Because you have opposite and adjacent.
That's perfect. I mean, that's it. That's it. I mean, you did it. So we're going to say tan 27 equals 16 over x. Now, one thing Brenton said that I want to catch real quick is, he said, would you use tangent or cotangent? You absolutely could use cotangent, but I wouldn't recommend it because we're going to get our calculators out and we do not have a cotangent button. So if I know I'm going to my calculator, I prefer to stick with the big three, the ones I have buttons for. I can do the other things, but why would I hassle when I can do it in terms of tangent? All right, so we're going to multiply by x and divide by tangent 27. So x is going to equal 16 divided by tangent 27. Oh, you better, what did we forget to check? Make sure you're in degrees. Make sure you're in degrees. Now, this time it was easy to catch because if you were in radians, your answer came out negative. And you're thinking, whoa, that can't be. Well, sometimes you don't catch it that easily. So we've got to get in the habit, and I'm as guilty as you are, but we've got to get in the habit of checking that mode. I want to be in degrees, I need to be in degrees because this is a 27-degree angle. And if you are inputting an angle in degrees, you got to have your calculator set in degrees. Otherwise, you'll get the wrong answer. So what is the right answer? 31.4. And if this was feet, then that would be 31.4 feet. Got it? All right, the last one on the sheet. Now, here is something that I don't know if it's going to be an issue for you or not. When I see a tangent, that is different than when I see an inverse tangent, okay? So the rules we learned about quadrant 1 and quadrant 4 for this go with that. They don't go with the regular tangent. The regular tangent can be everywhere. Got it? So you only worry about that quadrant 1, quadrant 4 stuff if we have the inverse notation.
There's a negative tangent, so it would be second.
Yes, well, 90 to 180. So that's going to be in quadrant 2. So there's my butterfly bow tie in quadrant 2, and they tell me quadrant 2 because they say you are between 90 and 180. Isn't that quadrant 2? Right? Okay. Tangent is -3/5. Notice where I put the negative. The negative does not go on the 3. Does everybody see that? Doesn't make sense for the negative to be on the 3. The Pythagorean theorem would say the hypotenuse is square root of 34, 9 and 25. And then the question says, what's the cosecant? So what's the cosecant? Root 34 over 3. You are perfect. Very nicely done. All right, so that little review is done. So we're going to go to lunch. Time out. Let me see when I need you back.
All right, you ready for my snack then?
You know what? I just love you people so much. I'm going to give you till 12:20. But I want you back in your seat at 12:20. Got it? Nobody's strolling in at 12:20. We are parked in our seats at 12:20. Maggie, would you turn that on? Thank you.